Okay. I'm going to record the class tonight, and then I'll upload it. The Wi-Fi's not working very well, which also might cause us problems with, we'll see. We'll do what we can do. But this is where we're at. We had the exam last Wednesday. We didn't do the introduction. We reviewed the exam, those who were here. And I am still looking over. I got about halfway through the exams on the corrections, and I've started posting the revisions to the grades, so you should see those. And what we will have, though, is we'll do Unit 9, and today we'll probably get most of it done. Whatever we don't, we'll finish up with on Wednesday. We'll start at the 10, which is very related. So basically today we're looking at something called slope, or the steepness of a line. When we get to 10, we look at the equation of the line, what it looks like mathematically, so it kind of just builds on what we do in 9. And then 11, we look at more equations of lines, but in different forms. So these next 3 units really go together real well. And then Unit 12, we look at finding the intersection of 2 lines. So we take the equations and we have we actually have 3 different methods that will show you to do that. And then we've got a whole week to review units 9 through 12, and then we'll take our last exam on units 9 through 12. We do have it scheduled for Monday, so it's early in finals week. So if things don't turn out as well as you'd like, we can make some arrangements. We'll work with you. But I think this is one of the units. Typically, students will just do better and better and better as we go, because this particular 4 units is really compact. Of course, once you start understanding it, it's all good, because it's not too much stuff. It's all the same type of stuff.
From 4 to 5:50, is that the right time?
That is the right time.
Okay. So we wouldn't have extra time for them.
As long as nobody's coming afterwards, that's what we have to check. Because the college sets the times based on everything else. We don't have a class that meets in here after us, so this is because since we start at 5:25, it's one of those, if we would have started at 5:30 or 5:35, then we would have been in the later time zone. So I think we've actually got plenty of time. But again, it's a 25 question test, just like before. There's a full 2 hours, so actually I think that's more time than we usually get already. But, I've never cut anybody off, have I? You haven't seen it, but I haven't made anyone
Don't stress
stop.
her out already.
Yeah. You'll have as much time as you need. And again, before we'll have a practice test. Again, it's only on the 4 units, so the nice thing is we're not reviewing 12 units worth of stuff, only 4. So kind of think of it, you've already taken 2/3 of the final. Yeah. So, okay, any questions about where we're going, what we need to do? Or again, if you have issues with, maybe you've got 2 or 3 other exams on that Monday, and you need to do it another day, we can make arrangements with the testing center. I'll also, as we get closer, I'll publish my other times for my other classes. So if you want to come take it, if another time works better, you can come and take it with one of my other classes. I just make sure I give you the 091 test, not the other one. But and there may be people from other classes in here, so we'll just make it work. Okay. And if there's, if none of the times work, we'll always make something work. Okay. I know also with summer coming up, some of you may have travel plans or something. I'll work with you. Okay. Most people that, if you've already bought the tickets, you've talked to me. At least I hope so. But we'll make it work. Okay. So far, so good. Okay. So I'll keep working away. If you didn't get a chance, or you want to take another look at your tests, I've got them here, like I said, somewhat arranged, I think, because I'm going through them. And test corrections you can do and get like half the points back is how that's kind of working. Okay. We are recording, but it's not live. So what are we going to do today? Looks like I've got connected now, so hopefully okay. Yes. At the, yeah, when we get done with the lesson, I'll get those back to you. If we can ever get started here. So I'm trying to see if I can, hey, it's working. Using my hotspot, so it might be a little bit slower, but here we go. So we're going to get into 9, and again we have the 4 sections. There is an online review for the 4 sections, online homework, so that's also a good way to get in there. But we'll also have a paper review, and we'll have a full week to review things. So we're going to just go ahead and download the workbook. Actually, I should have done this earlier, but let me see if I can. If I do this, then I won't need the internet. Okay. Just close this out. So what is a line? How can you describe a line?
One point to another.
Connection between 2 points.
something connecting 2 points. Okay. So I got maybe 2 points here. Can you connect more than one line? If you've got 2 points, can you connect more than one line to those 2 points?
Yes.
How would I do that? If I could bend it, right? So once you got 2 points, if we could draw it here. Let's see. If I choose one line like here, if I identify 2 points, the only way to get another line to go through there would to curve it, right? So, and we talked about curved lines when we talk in English, but in math, when we say the word line, we mean a straight line. Okay, so we don't have curved lines in math. It's opposites. So all lines are straight. And so that's why there's only one way to connect 2 points with a straight line. And that straight line is also the shortest distance between those 2 points if we're on a flat plane. If you're flying in an airplane, you'll see that a lot of times airplanes don't fly, it doesn't look like a straight line. It's because they're on a globe. And so they actually fly in different arcs, that there's actually less miles flown when they do an arc rather than what might look like a straight line. Okay, but that's because they're on a curved shape. But for a flat ground, two points, connect them, you got a line. Now, are these the only 2 points that are on this line? No. But 2 of them will define a line. We actually have an infinite number of points. There's points all over this line, right next to each other, and so, but 2 of them will give us a line. Okay, and we've got straight lines. So lines do not have a curve; they're just straight. Do they have thickness? Is there a difference in their thickness? Can you have a thicker line and a thinner line? We do on the drawing, but in the concept of a line, it actually has no thickness at all. A point is just a location. It actually has no, this also gets into philosophy and stuff. You say, how can a line not have any width? You wouldn't be able to see it, right? But the idea is that all lines have the same width, which is 0. They don't really have any length. They're just a sort of a direction connecting 2 points. And then they go on. Also, all lines are the same length because they never start and they never stop. They go on forever in both directions. Mathematically, that's when we talk about a line. So they have the same length. One line is not longer or shorter than the other. So there's not something different about that. So far we've talked about how they're not different. How are lines different?
They don't meet or go in different directions.
Okay. So how many lines are here? A bunch, right? What's the difference between all these lines? How could you describe the difference between, say, this line here that I've got the 2 red points on and slope, huh? Or let's see if I can stay on the right. Is that this one? Okay, sorry, so there's too many lines to figure out. The green line, so we something called slope. What you call it? Angle. We also might refer to it as steepness. So that's a quality that can differentiate the lines. We can talk about a line that's steeper, a line of different angles, measuring an angle from someplace. That's what you'll do if you take trigonometry. They talk all about angles and stuff. In this one, we're going to define the slope in a certain way, and we'll do that tonight. But yes, this line here, the green line, is actually somehow steeper than the one with the red dots. Would you agree with that? Mm-hmm. Okay. They're both going up, so there's some lines that are coming down, right? So those, and again, if we go on to a single point here in the center, like is shown, we actually have, if you want to talk about angles, 360 degrees, we can go around and have lines all over this place, right? Okay, but that's one main concept of a line is that it has a particular steepness, either big steepness or little steepness, slope. and that's what we're going to talk about in lesson 9, just the slope. Okay. The other thing that can differentiate a line is it's like if I got this red line, I could have, I'll do it in red. Actually, let me go up here. Draw a red a line. So I could be parallel. I could have the same steepness as this line. Let's see if I can do that. Yeah, it's about, let's say, so they're parallel lines. They have about the same steepness. That's at least my intention. But how are these two lines different? The one with the red dots and the one that's red. Since they have the same steepness, the same slope, how can you differentiate between these two?
Where they start and where they stop.
Good. One is higher than the other. Okay. So where we'll make that measurement is right here at the y-axis. So we're going to remember we've been talking a lot about y-intercepts. So we're going to carry that forward because that's an important aspect. We're going to talk about lines. We're going to identify them partially by where they cross the y-axis. So their y-intercept, these two would have different y-intercepts. We'll see they'll have the same slope, so that's not different. But what is different is they have different y-intercepts. And if a line has the same y-intercept and the same slope, what do you know about it, those two different lines? That they're actually the same line. Because if it's got the same y-intercept and the same slope, there's only one line that can connect those two because we don't have the curved lines. Okay, so this is the big overview of what we're going to talk about. 9 and 10. 11 is sort of is related to 10, so it's just writing things in a different format. So today is the big start of it, and all we're going to talk about is how to measure the steepness of a line. We could do it in multiple ways. We could do it with angle measurement, but we're not. That's your trig class. You'll measure with an angle. Say, well, that's a 45-degree steepness. Here we're going to do it a little bit differently, so we'll just get right on into the introduction. Save this, and we'll move forward. And we're going to hit off that concept. Again, here's some other types of lines, some horizontal lines, some vertical lines, and then lines that are going up and lines that are going down. Okay, and we'll talk about how the slope looks like for each of these by the time we're done. And what I want to do is just jump to an example, and then we'll explain this. Let's make it a little bit bigger, because that's all we need to talk about is one example at a time. So I'm going to do this two ways. First, visually, I'm going to plot the 2 points. So that does take us back to 5. It's like we're not going to test you on it, but to be able to understand this, you have to know what we were doing before. So let's see. What color should we use? How about blue? Is that okay? So where's -2, 3? We start at 0, 0, -2, and up 3. Is that correct? Okay, so there's the 1 point. We'll go ahead and label it -2, 3. And then we've got another point for -1. So starting at 0, 0, 1, 2, 3, 4, and down 1. Good. So you can kind of visualize a line that would connect these two. Maybe better than I can draw it. 4, -1 is what we just drew. Let's go ahead and give it a line. Any preference for color? Green. Green? Let's go with green. Okay, so I'm going to connect them. So here's one going through this point. And then I'll do it the other way just to make it a complete line. Going up this way. There we go. And I sort of didn't quite make it exactly through that point, but we'll just kind of pretend I did. Okay, so the drawings are right there. So how could you describe this line with some words we've used before about graphs.
It's decreasing.
Decreasing, because from left to right is going down. Good, so it's a decreasing graph. So what kind of a slope would be good for a decreasing graph?
Negative.
Perfect. So does it make sense that it would have a negative slope because it's going downhill? We'll do the calculations of how we're going to, but yes, you're right, it's going to be a negative slope.
Will we also like run very similarly to like past units, like how, is this a solution, does it check and everything? You know what I mean? Yeah.
Yeah.
Okay.
Yeah. Well, yeah, we're going to look at multiple ways to actually calculate the slope of this line. The thing that we're going to notice, though, is that everywhere on this line, the slope is the same. From one point to the next, to the next, to the next. Because it's straight, slope on a line does not change. Once you know its slope, you got its number. Okay. You know it's how steep it is. It's that same steepness all the way along. Okay. So here's what we're going to do. We're going to define slope. Now this is the part where it could have been decided anyway, or different ways. Go ahead and use red. We're going to define slope as a ratio, not as a degree, not as an angle. So slope is a ratio. What's a ratio?
It's a division.
It's a division.
Fraction.
It's a fraction. It's something over something else. So a ratio. What would be appropriate when we're thinking of slope? What might make appropriate ratio? What are kind
X
of...
over Y.
There we go. We got a change, and we're going from this point to this point. So we can think of slope as not being at a place, but how much we're changing from one place to the next place. And that's exactly what we're going to do. Now we could do it x over y or y over x, and we would, depending upon which one gets chosen, we'd have a different type of mathematics. So to fit with the way that the books do it, everybody's decided on. They didn't ask me. I actually always did it backwards for some reason. But then finally I figured out, well, if I'm going to pass this class, I better do it like everybody else. We're going to do the y's on top, the change, and actually we'll use this little triangle. That's a little math symbol for change. So you see, it's actually a Greek letter, delta, and they use delta for change. Okay, so the delta y over, like an earthquake there for a moment. Oops, not over delta y. Delta y over delta dawn. No, delta x. Okay. I don't know, I was watching TV. I don't watch TV a lot, but when I do, it just, and they had that country music. Did anyone see that country music video?
Oh, yeah.
From all the, and they were singing Delta Dawn, and I said, oh yeah, I remember growing up with that one. But this is delta x, yes. Delta y over delta x. So the change in y over the change in x. And we're going to calculate these in at least two different ways. One visually, and again, if you have difficulties with this, you might want to go to the visual. To do the visual, you have to plot the points, and then just, it's counting, okay? We'll also do it with an arithmetic from Vedic math 3,000 years ago. And then we'll also use an algebraic formula, and we'll see how all three give us the same answer. So then you get to choose which one you prefer to use. Okay. So first of all, since we've got it drawn here, can we calculate the change in y? How would we do that? Just count, right? 1, 2, 3, 4. We went down 4. So how might you represent that?
-4.
-4. So down is negative. And if we go backwards, that would be negative. If we go up, it's positive. If we go to the right, it's positive. Okay, so from here, how far do we go to the right? 1, 2, 3, 4, 5, 6. And that was in the positive direction, so we'll label that as a positive 6. Which one is the change in the y direction?
-4.
So this is our change in y. So that must make this the horizontal change, and exactly it is. It's all very visual. And so it's going to be the change in y over the change in x. So simply put, it's going to be -4 over +6. That's our ratio. The only thing we're left to do is possibly reduce it if we can. Can we reduce that fraction?
Yeah.
Because 2 goes into both of them, so we can divide both the top and the bottom by 2. And so we can say that finally, the slope of this green line is equal to -2 over 3. Does that seem reasonable? We said that since it's going down, it's decreasing, that the slope should be negative. It is with this method. Does that make sense? It's going down. And let's just check it out. It's in the reduced form. This is a change in y. So if I come down, let me change my colors. Let's go to blue. Yes. If I come down to 1, 2, and then I go over 3, 1, 2, 3. Oh my goodness. Look, I got back to the y. Isn't that amazing? What if I went over 3, 1, 2, 3, and down 2, 1, 2. Oh my goodness, I'm back on the line. See how that slope works? I use the change in the y and the change in the x. I can sort of reverse the orders I do them in as long as the bottom part is always a horizontal change, and the top gives me, I'm doing a vertical change. Now what do you think is going to happen if I come from this point? What if I go down 2 and over 3? I'm back on the line. Okay, see that slope? And it will happen forever and ever and ever. What if I went down 4 and over 6? I'll end up back on the line. We know that because this worked here, so that'll work. What if I went down 8? If I went down 8, how far over would I have to go? 12. So any ratio of these. Does that make sense? Did I lose anyone there?
No.
Please tell me if I did. Okay, I would have lost myself because I'm very visual. But yeah, so we've got a slope. We can think of it as -2 over 3, which is really the same slope as -4 over 6, which gets us back to the same place as we could go -8 over 12, and so forth and so on. Okay, but those ratios are all reduced down to 2 over 3. And you're going to see we're going to do this both ways. We're going to take 2 points, find their slope, and sometimes we'll give you a point and a slope, and you'll be able to come up the line. Okay, so we're going to use the slope in 2 methods. We're going to use it by finding the change between the 2 points, but we're also going to use the ratio itself to get from one point on the line to another point on the line. Does that make sense? Okay, and it always works. It always works. It's kind of cool. So let's take a look now with all of this going on. I'm going to give you the first sort of analytical way. So this will be a way of getting the slope without actually drawing it, just doing some math. How do we calculate change in math? If I changed from 7 to 4, how would I calculate that change? What's the math behind change?
Divide.
That gets us a ratio.
Doing one side to the other, or?
You're close. It's one of the 4 arithmetic operations. So but it's not division.
Multiply.
And it's not multiply.
Subtract.
It is subtract, yes. Subtract gives us the change. So going from 7 to 4, 7 minus 4 is 3. We changed our position by 3. So this is amount of change. You're correct in that division would give us a % change. And you'll see that that's a little more advanced in the next class, 121. We talk about % change. That's what exponentials, and the % is a type of change. This the amount of change we do by subtraction. Okay, so if we subtract from one point to the other, we get we get the change. And remember, that's what we're looking for here. How much are we changing? So what I'm going to show you is this. You probably you won't see this in the book, and you probably never had another teacher teach this to you, because I never had a teacher teach it to me. I read in a book from England that was writing about the way they did math in India, and this is where it comes from. It's a 3,000-year-old technique from India. So what they did is they have this thing called vertically and crosswise, and all we have to do is line up the 2 points. So we've got these 2 points. I'm going to do it as, and it doesn't matter which one you do on top, but I'm going to do 4, 1 on top, and then right below it I'm going to write the point -2, 3. What I'm going to do is I'm going to subtract the bottom point from the top point, right? Because subtraction gives us the change. And remembering, this first coordinate point here, is that the x or the y?
Yes.
It's the x. So the second coordinate is the y.
It's a -1.
Good. So it's 4.
No, it's,
Subtra-
you need to put a negative by your 1.
Oh, but then I'll get the correct answer, and I don't like correct answers. Always forget a negative somehow, right? But that's why I have you guys. As you're watching, you're keeping me honest. Okay. When I take a test, I want you with me too. So, and that's when you'll see the reviews. That's what I was wanting to do. Is just that sometimes there's a simple error that you are making. If somebody would have watched or pointed out to you, you might not have made it. So that's why we do it this way. Okay. So then we do 4 subtract -2. So minus minus 2 is like plus 2, right?
Yeah.
So 4 plus 2, 6. And then -1 subtract 3. -1 subtract 3. Same sign, so I add them together. -4. And then since this is the x and that's the y, I take the x, tuck it under the y, and look, I got my slope. -4/6. Okay, so it's -4/6 is my slope. I reduce it, divide both by 2, so this becomes 4 divided by 2 is -2, 6 divided by 2 is 3. I get the same slope. So this way, I'm able to actually get the slope, the value of the slope, without having to draw the picture.
It's a hell of a lot easier than faster than putting it on a graph, just subtracting.
Yes. But I wanted you to see it, and this is the method this is one I use all the time. Because I don't want, who's got a graph paper laying around anyway, right? But I want to show it to you that you could see, okay, this is all it is we're getting, sort of measuring how much down and how much over, making a ratio. We do the same thing. If we've got the numbers, just subtract them, move it underneath. That's all there is. And you're going to be a master of this section real quick. Okay. Really. But see, nobody teaches it that way. What they teach, maybe I should take a picture of this, because this is the beautiful part. I'm going to show you the ugly part next. That took me years of therapy to get past and finally understand.
Well, thank you for sharing with us.
Sure. So I want you to have that same experience too. But no. It's because I'm dyslexic, and notice that this subtraction. I'm going to show you the formula in a minute. There's multiple places to mess up with the formula, putting things in the wrong place. Sometimes I put the x on top and the y on the bottom. You'll see sometimes I switch things around. But if I do it this way, by writing out the point, I can never mess it up because I'm just copying the point as it is. Notice. So now that I've got a picture, what I'm going to do, I'm going to get a clean screen. We're going to take these same points and we're going to do it algebraically. We'll come up with the same answer, but I think you'll find, at least mentally, it's harder because you've got to get everything in the right place. So what they do is whoever they is, right? So what they do is they call the first point x1, y1, and they call the second point x2, y2. Okay, again, if you just kind of want to check this out and say, I don't care about this, that's fine, because I got a method, we've already got a method that will always work. But what then they do is they say, well, the slope, what is the slope going to be? Well, it's the
Y2.
Change on y
y
over the change on x.
change in x. So that must be y2 minus y1 over x2 minus x1. That's how, and the reason I show this is a lot of the students I went to school with found this a very easy thing to do. I didn't. Some of you may have learned this way, so this might be, and it might work just perfectly for you. So that's fine. I show it, and it's what the book shows, so maybe it helps, okay? But I just want to show you, I give you that one extra of the Vedic math way.
So how come you put y2 before y1?
Because I wanted to.
There's no real reason.
Right.
Okay.
Because I could call either one of them y2 or y1. It was arbitrary.
Okay.
You'll see if you do y1 minus y2, as long as you do x1 minus x2, it'll be consistent and you'll be fine.
Okay.
But the thing you can't do, you can't put y1 minus y2 up here and then x2 minus x1. That's one of my favorite errors to make. That's why I don't use this. It's because when I copy over to actually do the calculation, this is where I usually would get problems. So I take y2, whatever you want to call y2, so let's call that -1, and y1 is 3, so we subtract 3. So notice the calculations are going to be very similar to what we've been doing. And then the x's, see x2, that's 4, and we're going to subtract x1, which is -2 minus 2. Okay. So again, some of you, that's not a big deal. It might be helpful to learn how to plug into formulas, but again, it was something that really held me back for a long time. And then when I found the Vedic math stuff, and it wasn't until I started teaching it that I found the Vedic math stuff, and now it's a lot easier for me. And it's a lot easier to teach. What's -1 minus 3? We've seen that before in our calculation. A negative makes a plus, so that's 4 plus 2 is 6, same slope, and then we can reduce it to -2 over +3. So we end up with the same slope. It's a third method. It's the method that's used in the book, and if you watch the videos in the mini lessons, that's primarily how they will go about doing it. Again, for me, this was not helpful. It was not successful. I found my workarounds, and it's basically the same calculation as we were doing with the Vedic math. And I'll show you. I could put -2, 3 on top, and then I could put 4, -1 on the bottom, and I'll do exactly the same thing, subtracting the x's, -2 minus 4. That gives me -6, and you'll say, oh, there's a problem there. Remember, we had +6 last time, but watch what happens. -1, that's a plus, so 3 plus 1, I get a +4. When I take this -6 and move it underneath, I still get a negative slope, positive over negative. I get 4 over 6, which still reduces down to 2 over 3, and there's the negative. The negative, it doesn't matter whether it's in the bottom, the top, or out front. It's all a negative slope. Okay? So the reason I prefer this one is I don't need a formula because it's a visually based. I just put the points, the coordinates in their place, and I just subtract straight down, and then I tuck the x underneath the y. And by doing that, it's a visual that I can follow through, and I don't have to have a formula. When I use the formula, I personally have problems. If you don't have problems with it and you like the formula, I'm happy to have you use it. But if you've had problems with it before, or it doesn't look like it looks confusing because of all these little sub numbers, that's fine. You will you know, you go further in math, you'll see some more of these things, and we'll deal with it at those times. But I think at this point, we just want to understand, we want to get to the slope, what the slope is real quick and consistent and always get it right. And what I found is if we use this little simple thing, we will always get it right. On top of that, I've got a template that I use when we get to 10 that applies this concept and another couple little things, and I'll walk you through that one. Again, 3,000-year-old techniques that don't need any formulas, but give you the right answers. And not only that, it allows you to work through the whole thing without fractions.
Oh,
Okay.
so this is just a formula that allows you to, for working with fractions, this one.
Right. Well, I mean, our answer ends up being a fraction.
Right.
But you're going to see when we get to 10, we start with this slope, and we're going to, there's another formula. We use this slope to find the full equation of the line. And if our slope is a fraction, it makes it a little difficult. But I'm going to show you a workaround from India from 3,000 years ago that actually makes it not so hard. And I can do this. I give you a template. It's a printed form, and I'll let you use it on the final. Because it's not notes, it's a template. So we'll practice. I've had a number of students who have found that method, it just works. I'm one of them. It really clicks. The other methods we'll show you, those are the same ones that get taught in the mini lessons and in the, you know, the workbook. So I'll show you both. But as far as I'm concerned, we're pretty much done here. So you can do this. Just line them up, subtract them, the top from the bottom. You'll be fine. Any questions? Okay, we're done. No, we're not quite done, but we're going to do a few more where we apply it. Okay. So I guess I'll take a picture of this one. And then we'll clear it out. Oops, that's not what I wanted. We'll go forward. I'll get a new page. Oops. Okay. How about this one? Should we take a look? Why don't you try it with one of the methods, the calculating methods, not the drawing method, but try to see if you can come up with a slope by, I'll set it up for you, just taking the points one above the other. So 3, 2, -1, 2. See if you can come up with the slope, just subtracting straight down and then divide by the x. Give it a try. We'll draw the picture and we'll see what, you know, because we'll see what happens. If you want to use the formula, that's fine too. Oh, shoot. And those of you who weren't here on Wednesday, I just grabbed the test, but those who weren't here, I've got them. Some of the tests are still on my desk, so we'll get those at the end. So we can take a look. How are we doing? Anyone got an answer yet? Subtract the bottom from the top. So what's 3 subtract -1? It's like 3 plus 1, so that's going to be 4. What's 2 minus 2? 0. Oh, does that mean we did something wrong? No. Feels right. It doesn't feel right. 0 is a number. It's fine. Yeah, we did it right. 2 minus 2 is 0. But it always gives us this feeling, doesn't it? Because we thought we were supposed to get a number, but 0 is a number. Okay. Then what do we do? The
0
x.
over 4?
Yes, 0 over 4. And what's that?
0.
It's 0. Okay. So are we saying that these 2 points are that they have a 0 slope? That is what we're saying.
They have a 0.
Let's plot them and see why they have a 0 slope. 3, 2, 1, 2, 3, and then up 2. So starting at 0, 0, right? There's 3, 2. Negative 1, 2. Negative 1, 1, 2. What kind of line is this? It's a constant. It's a horizontal. Y is always 2. The equation of this line will jump to, we'll learn more about this later, but it's actually got a very simple equation. It's really just y equals 2. X can be anything. We'll see that. That's a preview into 10, but it's a horizontal line. This does have a 0 slope because there is no rise. It's all run. Okay. And sometimes these are the hardest lines to deal with because they're so simple. There's just not a lot to work with. The 0 just doesn't feel right. It feels like we did something wrong oftentimes. But this is, it's a horizontal line and it has a 0 slope. There is no rise. It's all constant, no change. And that when we talk about change as being up or down, at least no change, just run.
So that's y equals 2 less than.
We're going to see that, and that we pick up in lesson 10. So I'm getting, it's not in 9, no. I give you some previews just to kind of say that. The thing is, when we get there, y equals 2, it sometimes seems like such a hard thing, but it's really a very simple thing. Okay, so far so good. Does that make sense now with the picture? I mean, does it make sense that this would have a 0 slope? Because it's just like level ground, you know? You're not going to roll downhill or, you know, or have to climb uphill. It's just straight, and that's what a 0 slope means. Okay, so that's why we have this. Is sometimes when you see the visual, that will help you. And we've got this right. We can also do that formula thing, right? Y2 minus Y1, or whichever way you want to go. It's kind of hard to keep track. And then you take X2 minus X1. Again, as long as you keep the order same, you're fine. So you end up with 0 over positive 4, which is 0. So you could do it this way, or just line them up. And I just found it's easier to do it this way for me. And then I always tuck the X underneath. And then I don't mess it up. So, because the other way, sometimes I'm putting the X's on top, the Y's on the bottom. And that could work, but everyone would have to do it that way, and they don't. Okay, so far so good. So again, this is a special case one, and so we want to remember it, and we will be running into this consistently. Notice this line has no horizontal intercept, right? Because it's parallel. It does have a vertical intercept. Again, I'm just kind of looking down the line for what we're going to get into 10. So as you do these, if you do take the time to go through the workbook and plot them and see them visually, put those things in your mind, because part of what we're going to be doing is we're answering questions about lines, and there's a geometric part of it, and then there's an algebraic part of it. And if we can put those both together, we'll understand it much more deeply, because we can see the pictures. Remember, our minds, our brains, actually think best in pictures. We're really all visually. Some people get into the abstractions, but even then, when they're abstracting, they probably got some sort of abstract art going on, like a Picasso or something. But it's still visual. It's still visual. Okay, so let's clear this out, and let me go down. I think the next one is going to be let's see. Yeah, this is going to be a good one. So give this one a try. It may look like it's the one we just did, but it's a little different. Find the difference, find the slope, and we'll see what happens with this one.
This Bless you.
Again, if you want, just put one of the points over the other. Subtract them, and you'll have your slope. You might even be able to do it visually. Just look at them, boom, 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 there it is. So 2 subtractions and a division, that's all slope is. 2 subtractions and a division. And that's really all 9 is we're going to just be using the results of these. Anyone got something yet?
-4.
Zero.
So that's where we're on -4.
Negative
So
four.
-4.
So 2 minus 2, 0. Is that okay? Of course it's okay. It's okay to have 0. So then that is 0, right? And then -3 minus 1,
-4.
-4. What do we do with the x?
Under the Y.
Tuck it underneath the y. What's -4 divided by 0?
Can't.
Can't do it. It's against the law. Because when you do it, what does your calculator say?
Divide by 0, error.
Error.
Mm-hmm.
So this is, and I'm going to show you this one. So what must this be? The last one was a horizontal line.
Vertical.
It's a vertical because the x's are the same. Okay, and I'm going to, I have a different answer for this that they don't ever let me use, but I'm going to do it anyway. So 2, -3 is there, and 2, +1 is there.
Bless you.
And so yes, indeed, if we connect these 2 points, we do get a vertical line here. Can anyone guess what the equation of this vertical line is? Again, that's ahead of, the last one was y equals 2. What do you think this one is? It's x equals 2. Very good. So these are going to be our very simple ones, but that's also what makes them sort of hardest to understand, is the simplicity of them. And they are the extremes. They're like your left wing and your right wing. They're your vertical and your horizontal. They're the extremes. Everything else is in between. Okay. They call this, in the book, and most books will call this undefined slope because division by 0 is undefined. But when you say it's undefined, what are you really being? A wimp, aren't you? Here's that, I don't know, calculator can't do it. It's just, let's just say it's undefined and go on, right? What would you call that? Can you get any steeper than a vertical line? No, because if you got any steeper, you'd be going back down the other way. You'd be less steep, right? This is the steepest line that we can make, a vertical line. This, and you give it the name of undefined slope? How wimpy is that? How about if we called it like something really cool, like infinite slope? Can you get any bigger than infinity?
No.
If you could, then you'd be at another infinity, right? So, and that's actually what it is. And if you look at math theory, later on, they have some tools, and there are places that actually define division by 0 as equal to infinity. The problem is infinity itself is not a number, it's a destination. It's a place you're going to, because if you got there, well, you're not there yet, you still got to go. It's like, your kids in the back, how much further, Dad? Infinite amount of time. We're going to be driving for infinity. It's a long time. So you never get there. That's, you never, and if any of you have kids, you don't tell them that they'll start jumping out of the car or something. We were going down to Mexico. We were supposed to go down to El Sonora, And it just seemed like forever and ever. We stopped at a bathroom. I was going to hide out back. I said, I'd rather just move to Mexico because we're never going to get there. And each time the bathrooms got a little bit worse and more holes in the doors and stuff. And I was just going, I'll just hang out here. Like I can see the beach from here. I'll go, whatever. But infinity. And this is where I believe most students get confused because of the undefined slope and zero slope, right? Undefined and zero. Doesn't it sound kind of like they could be the same thing? And a lot of students will confuse them to be the same thing. But if I call the horizontal, which is no slope, zero slope, I'm on my roller skates, I'm not going to go uphill, downhill. Zero slope. I can park my car without a parking brake, right? Zero slope. It's not going to roll on me. But if I call the vertical line like infinity, I will not mix those two up. Can you mix up zero and infinity? I don't think so. Infinity is like the biggest, the steepest. You'll remember that infinity slope is the vertical line. Zero slope is, I can park my car without the parking brake. It's not going to, I can leave it in neutral. And then Thailand, we do this because you got to be able to push the cars around. There's so many cars, they park. Yeah, you go to the shopping mall, they park, 2 or 3 behind them, and then when you need to get out, you push cars. It's like a little Tetris game. It's kind of fun. Get your exercise. You push everybody's car, but be careful. You don't want to, bump the cars into each other, but you just make room and get in and out. Yeah. Yes, sir.
There was a time, you just read me a story, but there was a time I was on a field trip in middle school, and there were, it was like a bunch of middle schools, and my teacher was driving one of the buses, he put the parking brake on, and there was one, it was like facing another bus, and I'm like, why is it doing this? There's no one in there, and it bumps into the bus, but it wasn't at speed because it was closed, so
Yes.
it was just like, wow.
Because they weren't on a zero slope. You want to make sure you're on a zero slope, okay? Zero slope is no rolling. Infinite slope, again, you just have to remember that's what they call the undefined slope. If you're a skier, you don't want to try to ski down a cliff, unless you're more gutsy than I am. I would not like to ski down a cliff. I want the bunny hills, ones that are. Actually, I like zero slope. I like cross-country skiing better because I can stop anytime I want. You can put me on the mountain, any kind of slope. No thanks. Okay. So infinite slope. So tonight we pick up those. Those are the two extremes, but they're also the two that can cause the most difficulty. But don't let it do that to you now. You know that this is an infinite slope. We'll come back, we'll call it undefined. But also notice with this infinite slope, we've got a vertical line. Notice we do have a horizontal intercept, but no vertical intercept. I think we talked about this before. And I won't get back into that other conversation, but we talked about horizontal and vertical intercepts when we have them, when we don't. Okay, we're going to revisit that in lesson 9, actually in lesson 10, because it becomes important when we're getting the equations of lines. So, and those of you who did well in lesson, I think it was mostly lesson 6, we were talking about intercepts. It'll come back, not directly the same, but it'll be in here. So you'll see that. Okay, so far so good? The new screen. So we've looked at the two extremes. You could do all that, but we've done it, right? So now what I want to do is I want to show you, because we'll have some problems like this, where if I've got a line, I can get the slope of that line simply by visually looking at it. Okay. So unfortunately, it gave us too much information up here, but just sort of ignore it. So on this, how would I go about finding the slope of this line?
It's a point.
Find a point, any point. And the points we want to use is like I could use this point here, but notice it's not in the crosshairs, as I call it. Try to find a point that's sort of right there in the crosshairs, and then find another point. See, that one doesn't quite get there, so I don't want to use that. I don't want to use that. Here's a nice point going right through a grid, right? I'm not quite sure what to call that, but do you understand what I'm saying? Sort of where the grid, a corner of a grid. Okay, those are the two I want. Okay, I didn't want these ones because it's not on the corner. And so now I can calculate slope. I can go rise over run. We call that, right? Change of y, which is a rise. Oops, not right. So I go up till I hit here, and then I see that's going to be the y, and then I just count my run. So the rise is 2, and it went up, so would that be positive 2? Yes. Run is going to be 1, 2, 3, 4, 5. And that's a positive 5. And it's always rise over the run. Because that's the change in y over the change in x. So rise is 2, run is 5. And notice that's what they came up here. We could have also gone backwards, so we could have gone from this point, we could have gone down 2 and back 5. So that's where they're doing here, down 2 and back 5. That works as well to calculate the slope, but a negative over a negative is a positive. Okay, does that make sense? We can go either from Grandma's house to our house, or we can go from our house to Grandma's house. It's the same road. It's going to have the same slope, but the directions will be different, right? This way we did it, they're both positive. We go the other way, in red, we could have came down 2 first and then go back 5 and then had the ratio -2 over -5, which is also the negatives cancel 2 over 5 for our slope. Okay? And again, partly what we're doing is we're building up because eventually we'll be doing some graphing, so we'll use slope to draw the line. We'll have a point, use a slope to get another point, we get our line. That's all there is to it. That's all there is to it. Sometimes the problem you're going to have is that you'll start confusing slope with an actual coordinate point, right? Because a coordinate has an x and a y coordinate, right? And we locate these points by going in the x direction and then up in the y direction. So this point that I have here is the point -5, 1. But that is always, when we have a coordinate point, we're always measuring or counting from the point 0, 0. Okay? When we have a slope, we can start at any point on the line. We don't have to start at 0, 0. Like in this case, we would never start at 0, 0 with the slope. If I found another point, let's take this one. If I go up 2 and over 5, 1, 2, 3, 4, look at, I'm right back on the line. So I went up 2, over 5, and I'm at another point. Okay. It will always work that way. Okay. So slope and coordinate points, they may get to be where they're a little confusing because they're similar, right? A point, we go over the x amount and then up the y amount. Usually with slope, we go up the slope amount at the top, and then we go over the bottom amount. Okay, so rise over run. But just remember, slopes are ratios, and they tell us how to get from one point on the line to another point on the line. Coordinate points tells us how to get from 0, 0 to that location. Okay. But I'll warn you now, I'm sure some of you will make the mistakes as you get into it. It's all, but that's what it is. We practice and we'll see it. But if you're aware that that's going to be something that will happen, you'll start to confuse coordinate points with slope and slope with coordinate points. If you're looking for that, when it happens, you might be able to spot it sooner and say, hey, I just got a little turned around here. Slope is point to point. A coordinate point is from 0, 0 on. Okay. Okay, almost there. Let's see, figure out the lines. I'm getting some other practice to do with these. There it is. Okay, here's another use. And what we've gotten, we're given a point and the slope so that we can find a line. So in this case, this is where we might start confusing slope and coordinate points. But if we're careful and we do it slow enough and with enough intention, we know that -2, -3 is what? It's a measurement from 0, 0. So we go -2 and then down 3. This is really where the test of chapter 5 comes in, is going through here. And again, it's not so much that we're going to test you on it, but it's going to help you to understand how to build understanding of lines. Now, what does the slope tell us? What is this 1?
1.
It's a rise of 1. And what is this 2? It's a run of 2. So it tells us to go up 1 and then run 2, and we'll get to another point. How can we get to another point?
1 up.
Rise 1, run 2. We could do this all day long. We could have also gone down 1, and then what would we have to do?
Negative.
Go back 2, right? So if we went down 1, we go back 2, and that's still a ratio of 1/2. Okay, and notice down 1, back 2, aren't all these points on the line? Down 1, back 2, up 1, over 2, up 1, over 2. And sure enough, we can draw the line, and they are all points right on that line. Okay. So if I give you a point and a slope, you can use that slope to find other points on the line. Again, you could stop at 1 more point, because any 2 points will give you that line. But if you do it a few more times, it emphasizes it works. Gives me a bunch of points on the line, and that's what this is about. How's this feeling in comparison to the other stuff? A little bit
It's kind of similar in a way. Just
similar, but it's got the visuals and again, also the analytical side of it. Okay? Just come back. Back here. There we go. Just do some lines. Okay, and let's see. How do we draw something with undefined slope?
Maybe a vertical line.
Good. So again, maybe we come and say, it's not undefined, people, it's infinite. We know this. It's a vertical line, yes. So we go to 5, 2. 1, 2, 3, 4, 5, up 2. And we're going to have a vertical line. That's what undefined slope means. That's what infinite slope means. Okay, so it's just going to be sort of, it's kind of vertical, but you get the point. Okay, and what you're going to find is if you'll do both, if you'll take the time, if you don't have the workbook, just print out a few of these, do them a few, and it solidifies things in your mind, what a vertical line is, what it looks like, that it is undefined slope. Just by doing this, you get that muscle memory as well, rather than just looking at things. Okay. So those are drawing lines. Okay, let's see, what are they having us do here? Same thing. Give us a point and a slope. And they're going to ask for coordinates of at least 2 other points. So again, we use the slope to get there. I'll make this one a little bit smaller. Okay, so again, it's good to practice doing these type. So we go to the point 1, -2, 1, -2, plot the point, then use the slope. Now this is, what I want to show you this is because we've got a negative slope, right? So which way should the line be going? So if you go to the right, it should be going down. So since they got the negative in front, do we put it on the top or the bottom? What's the right way to do it? Top, put the negative on the top, or put it on the bottom? The top. Good. What if someone said you could put it on the bottom? Well, let's see, do they both work? So let's put it on the top, -3, 5. So what does that mean from this point? Where do we go? Down 3, and then over to the right 5. 1, 2, 3, 4, 5. So this was down 3 to the right 5. Sorry about that. If I do this one, which is +3 over -5, what happens? I go up 3, and then I have to go back 5. 1, 2, 3, 4, 5. I get a different point, but I'm on the same line. And actually, this is a nice way. I get a point on one side, I get a point on the other side. So this was +3 over -5. Now, can I do -3 over -5? No, because that would be a positive slope, and that would be in the completely wrong direction, right? That would give me some point up here, over here. Yeah, it's completely off the line. So if I've got a negative slope, I can put it in the top or the bottom, and they're both correct. In fact, I would say neither is more correct than the other. Doing both of them will be helpful. That'll give you your 2 points. You'll see they're on a line. And then just go ahead and draw the line by connecting the points. There we go. That's what it would look like. Okay. And again, what we're doing is we're helping you to build this visual understanding what slope is. Rise over run. So that's where the graphing is helpful. Some of you may decide to skip over some of this, but I would do at least one of each. And the more you do, the more you're helping your mind because you're giving it visual input, you're giving it pictures to think about as we talk about negative slopes, talking about undefined slopes, talking about zero slopes, talking about positive slopes, rise over run. You're actually doing it. Anybody do it in the roofing business or roof your own house? Up in Oregon, we used to do it all the time because there's so much moss. The pitch, that's exactly it.
They would do that a lot in Oregon?
What's that?
They would do like a lot of roofing like that in Oregon?
Oh yeah, because we got so much rain and you leak all the time and you got moss growing and yeah, everybody, and I don't know, there's just shingles, so you just put them off. And everyone I knew in high school, we'd all done our own roofs. We'd go around, we'd do our own roof, and then we'd help our friend do his roof. And down here you got those cement ones. I wouldn't want to do that. Those look heavy and you break them and stuff. So yeah, I don't want to mess with ceramic tiles, but yeah, Oregon, it was do it all the time. But roofing. I got 2 cousins up in North Dakota. They've done roofing. They decided, though, they asked for the pitch first because they did a church steeple once in the middle of winter, and one slid off, and it wasn't took them a while to heal up. So it was, so he says, yeah, I think it was a 30 pitch, but it was a real steep. They decided they shouldn't have done that one in winter. But that's what slope is, rise over run. And you'll talk about the pitch of a roof. That's exactly what they have. So far, so good? So it's just taking the y's and taking the x's, subtracting them, making sure the y's on top, the x is on the bottom. Rise over run. Simple, but also easy to get it reversed. Okay. And this is only 9.2, so let's jump a little bit further ahead. And again, we could label the points, which I encourage you to do. Let's see, what's all this? This interpreting slope. So, because slope is something. Where would we use slope? Anywhere we got a ratio. So we can plot someone's position over time on the graph. And then when the slope, what's the slope? Well, that's position over time is maybe miles per hour. We actually, their slope is actually their speed. Okay, so this is the slope itself gives us a new input into a picture. Change in heat over change in time. So that's, how fast is the temperature changing? That's sometimes very important because that allows us to predict what's going to happen in the future. So this is what the important part of this is. We're not just getting, remember, we get slope, we don't have a location. We have how we're getting to the next location. We have a predicting ability now. We can use math to actually predict where we will be in the future. So if you know how fast you're driving, and you're 60 miles an hour, and there's 60 more miles to go, how long is that going to take you? Do a little bit of math, 1 hour, right? If they're nice numbers. Or if you're 75 miles away and you're going 60 miles an hour, will you make it there in an hour? No. You got to go faster, or you just got to take the time and say, no, it's not possible. And especially we're going 60 and we're in a 45 mile an hour zone already. We probably better not speed it up anymore. I probably should slow down anyway. But you can do these kind of things. You can make predictions based upon the mathematics. So that's what the slope's getting us. This is the beginning part of calculus, actually. Calculus is all about rates of change, all about slope. If you understand slope, you understand what calculus is all about. And that's how they actually introduce calculus, is with the slope formula. So this is the basis right here for all the advanced mathematics that we do. Just a few steps away. Okay, understanding this. Feet per second, miles per hour. So this always gives us, again, how our situation is changing, maybe how fast it's changing or how slow it's changing, how two variables are changing over each other. So this is a very important aspect of mathematics for everyday life. Okay. So that's what you get paid in dollars per hour, right? Or unless you're salaried.
Yeah.
But if you're paid hourly, it's dollars per hour. So the more hours you work, the more money you're going to make, right? And the bigger your slope, which is what you're getting paid. I could go from $10 an hour to $15 an hour. That's an increase in slope. You like that, don't you? That kind of slope, yeah. You want some. I'd like some infinite slope there, right? My salary did increase infinitely, but it's a dream. But okay, but we want, yeah. So that's what slope comes to mean, is how much of a raise am I going to get? It's the change in something. Okay. And you're going to see we use the slope to calculate things. These ones I'm going to let you kind of work through. There's some graphs. Well, let's do this one together, and we'll see. Once we have a graph, when we find the slope, we can actually find how fast Sally's going. So this is Sally's distance from home over a 30-minute period. So this is time in minutes, and this is distance from home in miles. So how far away did she start? 15 miles. And 30 minutes later, where is she? How far from home is she here? 0. So this is x is 30, y is 0. Yeah. 30, 0. That's an x-intercept. This point up here, which is 15, is actually 0, 15. That's a vertical intercept. And let's calculate the slope. And you'll see why using the horizontal and vertical intercepts to calculate slope is such a nice thing. Because in one, the x is 0, so So 0 minus 30, negative 30. 15 minus 0 is 15. Take the x, tuck it underneath the y. 15 over negative 30, and that reduces down to what?
1 over negative 2.
1 over negative 2. And so the negative means what? She's getting closer to home. If she's going away from home, it would have been positive. So it's a negative change. It's going down. The miles are going down. What is this? What are the units on our slope?
Miles over minutes.
Miles per minute. So if you're going 1 mile every 2 minutes, how fast are you going in miles per hour?
30?
Good. It's a good call, because 60 miles per hour, 60 is a mile a minute. This would 1 mile every 2 minutes would be 30. You can do a conversion. There's 60 minutes in an hour, right? So we'll take 60 minutes divided by 1 hour. And when you multiply, you get 60 divided by 2. That changes it to 30 miles. And the units here is hours in 1 hour. Okay. And if you take Math 141, we talk about these conversions. It's not a real big deal, but you see she's going 30 miles per hour consistently on a straight line. Could we have chosen some other points? Sure, we could have chose this one. In fact, using the slope, since it's 1 over negative 2, we could have gone, well, probably want to think of it as down 1 over 2, or you could think of it as up 1, back 2, whichever way you want to go. And you can see all these points here. Up 1, back 2, up 1, back 2. We're always hitting those crosshairs, up 1, back 2. Okay, so that's a use of slope. Anyone else getting tired? Slope is kind of sinking in. Okay, let's just take, this was 9.3. I think we get to applications here pretty quick, so let's you can answer all these questions about it. Okay, so here's an applied problem. Let's see how we can do this. In applied problems, there's always a rate or a slope, and then usually there's some kind of a starting value. There's a value that happens once, and then there's a value that happens multiple times. And so you'll see most of these problems, when you get them, you'll see two numbers, and you got to figure out which one is the slope. How can you tell the slope from sort of the fixed value?
Well, the fixed one is the non-refundable fee.
It's a reservation, because you're only going to pay, you pay a reservation fee once. You reserve it and you're done. So that's a one-time thing, good. And then, so how about this 15?
That's going to be your speech.
It's a slope because it's for each room, so it's a rate, $15 per room. So that's what's going to be the slope. Okay, so 0 rooms, what are we going to pay? $25. Do 1 room, that's the reservation fee plus 15 more. $30, $40. Now, do we have to pay that $25 again? No. We do 1 more room, another 15. So each time we just add another 15 per room, because once we got them out there, we're just fine. Add another 15. So you see the slope is 15. We're rising 15. How much are we running? time we're running from 0 to 1,
One room.
1 room, 1 to 2, 1 room, 2 to 3, 1 room. So we can say the slope is 15, but we could also say it's 15 over 1. So when we have a whole number as a slope, always remember that it's got that invisible 1 underneath it. Rise over run. The run is 1. So that'll get you sometimes just when the slope is a whole number. It's actually a fraction, but it's a fraction over 1. Okay, so that might help you in graphing this, but you could also, this one's a very visual, you can just kind of keep going. So rise, so the run is 1, the rise will be 85. So just keep adding 15, adding 15, adding 15. And then you can plot it. So it's approaching the slope from a different perspective. Okay, but I don't know, for some reason, it just seems, in working with students over time, it's so easy to get these two confused. You use the 15 for the slope and the 15 for the phi. So just be careful. Just the one that is sort of for each or per room type thing, that's going to be your slope. One that's kind of calculated multiple times. And usually there's some kind of reservation fee. That's a one-time payment. Okay. And we'll see in chapter 10, we'll put this all together. Just to give you an advance, it actually gives us the equation y equals 15x plus 25. Okay, that's what we're going to do in chapter 10. We're going to actually come up with these equations. Do you see where did the 25 come from? The one-time fee. We pay it once.
That would be the equation to get to.
Yeah.
Okay. Oh.
Yeah. Plug in 0 for x. The 15 goes away. It's equal to 25. Plug in 1 for x. 15 plus 25. That's 40. So you'll see that you've got these. We were doing this back in 6, and I told you to skip it because this is what it wanted you to come up with. Wanted you to come up with this equation, but it was a lot harder back then because they didn't give you the tools. Now that we have slope, we're getting the tools to do this. We're actually not getting to the equations till we get to lesson 10, but I just want to preview you. We'll be getting there, and so each time we pick up this stuff, it will hopefully seem to be getting easier and easier because there's just one more thing added onto it. And if it's not, we'll work on it to get it. And I think the best way to make it clearer and more understandable is to do the graphs. Do the graphs, because then you visually see it. It really is just a mathematics of counting how much up and how much over. And when you do that enough times, when the numbers get bigger, you'll at least still visually see it. Going up and going over, there it is. You might not draw the picture, but if you can draw it mentally, it'll be a lot easier to understand. And I'll have students who do that method, and then when they make a mistake, they go, oh wait, that's going down, not up. It's supposed to go up, and and it's the visual part that gives you the clue to what's going on. Okay, so a few of these are good things to do. Clear that out, and we're about halfway through there, but I think, let's see. Yeah, here's this funky equation. I told you it'd be in here. Again, it's the same thing we're doing, but I just did it with the coordinate points. So this is determining whether they're linear. I'll tell you what, practice with the other stuff, and on Wednesday, we'll blow through this pretty quickly. And really, it's just calculating the slope multiple times to see if it's if it's linear, then all the slopes between all the points are always going to be the same. If we get 2 points and then 2 other points and they have different slopes, it's not a straight line, right? Because all straight lines have to have the same slope. So that's the test we do. It's just tedious, but it's doable. Okay, so you're just calculating the slope multiple times between multiple points until you just get tired of calculating slope. Okay, so there's a lot of these, and then they start giving you, here's the skills practice. Okay, so these are the practice problems. This is the end of the road, or the beginning of the road. We're back to the beginning. So here's some practice. So maybe you go through some of these, practice them by just finding the slope. Put one above the other, subtract them, tuck the x under the y, you've got your slope. Reduce it if necessary. And then on Wednesday, we can answer any questions. We'll go over this a little bit, and then we'll dive right into 10, because 10, we find the slope, and then what we do is we find that vertical intercept, the starting point, the y-intercept. We put that, and we add it to the function. We take the slope times x plus the y-intercept, and we got ourselves an equation. And we can do all sorts of math, and that's then from there, we're just going to apply it. But we now have a tool that allows us to predict what's going to happen in the future, predict what happened in the past. All these, we have some really powerful mathematical tools, and that's all there is to it. If we can subtract and divide, we got this thing licked. It's just a matter of getting it organized, and by doing the pictures, doing the graphs, you will get it organized in there, and you'll have a nice strong hand. Okay, sound good?
I see the connection with it from like the previous lesson. Wait, that's why it's like that.
That's why I was holding off. Say, don't do these until later,
I
because
saw
it'll
that
get
in
easier.
lesson 6 was it, I think?
Exactly.
And I was like, wait, what's...
Exactly.
No, I make the connection.
So if you want to take a look at your tests, I'll go run to my office, or if you want to, or you want me to just have them on Tuesday, or you want to take a look at them? Okay, Wednesday. Or if you don't mind waiting, I don't mind grabbing it so you can take a look.
It's okay, we saw.
Let me go grab them. I need a little fresh air. I'll stop this live, well, it's not live streaming, but
But you're